Hey class, welcome to Unit 5. The focus of this unit is on scatter plots and correlation. And so you started to look at scatter plots in Unit 4, but we'll look at them a lot more in depth in Unit 5. So on your screen, you see one of your Alex homework questions, and the data set is given to you, and you are asked to draw a scatter plot. I'll be showing you how to do this in Excel. I'll also be showing you how to calculate correlation in Excel. And I'll be showing you an Excel worksheet that's provided for you to help you in this unit, as well as how to create the equation of a line that best fits the data. So lots to learn in here, and Excel can help you with a lot of it. One of the first things I want to show you, and the reason I brought up this particular type of problem in Alex, is when you're asked to draw a scatter plot in this program, it's going to be really important that you're very precise with plotting your points. Otherwise, it will be counted incorrectly. So I just want to make sure that y'all are aware of this little feature right here where you see my mouse pointing, because it allows you to make sure that you get specific points plotted on the graph accurately. So if you look at the given data set, we can see that one of our ordered pairs is 13, 1, and then 3, 16, because each XY value is a pair, ordered pair. So in order to plot these 6 points, you can use this graphing feature right here. I'm going to click on it and show you. And it says plot a point anywhere. And it allows you in these 2 little ordered pair boxes right here to put in the actual points and just let the program plot it for you. So like with the first point being at 13, 1, I'm just going to type in 13 and then put the 1, make sure you get the order correct. There's the point. And click plot point so that it stays there. X that out, or actually you don't even have to X it out. You could now go move into the 3, 16. So 3, 16, there's your second point. Make sure you click the green plot point there, and you can continue on. So that's going to be the best way to draw your scatter plot, because if you try to approximate, it's going to be very likely that you're not exact enough to get credit for your response. All right, so that's that first thing. Now, the next thing, unfortunately, there's not a send to Excel icon to click on, so that the program automatically imports the data into Excel, but luckily it's not a very large data set. I'm not going to work this exact example, but I'm just going to work a similar one and show you how to do it in Excel. So let me open up Excel. Let me get a blank spreadsheet going here. All right. I'm just going to type in similar numbers. So 13, 3, 1, 2, 9, 4, but put some different Y values. All right. To get Excel to do a scatter plot, which you will be doing some of this in your discussions, then you just enter the X and Y values. Realize that Excel, whatever column is on the left, Excel is going to treat that as the X or independent variable when it does the scatter plot and when it creates the equation of the line. So I'm going to highlight both columns, click and drag with my mouse, and come up here to Insert, go to the middle chart section, and click on this one that looks like a bunch of dots, looks like a scatter plot, and in fact it is a scatter plot in Excel. So I'm going to click on that after I highlight the points, or highlight the values, and then I'm going to click on this first one, lift up my mouse, and there is the scatter plot. It is that quick and easy to do. You can add chart titles to get fancy. All you do is left click your mouse and change this. You can also add axis titles. It's always going to be good with graphing, and you will learn about this in the course, to make sure that your labels are clear, so that a reader of your graph would be able to look at it and know what the graph is about. As of right now, I'm not showing any labels. It would be very hard to know what in the world this graph is about. So that's where clicking this plus sign right here and checking the axis titles box will then allow you to take your mouse, click down here and change that to whatever your X variable is. Left click over here and change the vertical axis title to whatever your Y variable is. That's going to be really helpful. I'm not going to worry with that in the video, but it's going to be good practice for you all to learn to put labels on your axes and put a title on the graph. All right, correlation. Correlation is sample correlation, which is most commonly calculated rather than population correlation because we rarely reach entire populations. So the sample correlation is the symbol lowercase r. Excel easily calculates it by using a function, and I'm going to show you how to do that. You can go to any blank cell in the spreadsheet. I'm just going to click down here. Since it's an Excel formula, start with an equal sign and type in capital C-O-R-R, and you'll see that it already brings up the automatic function that you can just click on C-O-R-R-E-L, or if you want to just type in the rest of it, you can do that. So equal sign, capital C-O-R-R-E-L is the correlation function, open parentheses. Now notice it says array 1, comma, array 2. Array 1 needs to be your X values, your independent variable. So I'm going to now, after I've opened parentheses, take my mouse and click and drag down the X values, then hit the comma button on the keyboard, and then click and drag down my Y values. Close the parentheses, press enter on the keyboard, and there's my correlation. And notice it's a negative correlation, which makes sense if we look at our scatter plot because we see a downward negative trend. It's also a number that happens to be very close to -1, which also makes sense because a correlation coefficient of -1 would be a perfect straight line in the negative direction. Well, this one's almost, these points are so close and tight in a linear pattern, there's not a whole lot of scatter, that it makes sense that this is a very strong negative correlation that's close to -1. And again, these are all things that you'll be learning in this unit, a little bit of it in the last unit, and even more of it you will learn in Unit 6. So hopefully this is helping you to tie in some concepts together. All right, so that's how you calculate, that's how you construct the scatter plot in Excel and calculate the correlation coefficient in Excel. Now, the next thing that you will run into, let me show you what it's going to look like when you're in your homework questions. So I'm going to skip some of these parts just to mainly show you some new stuff that you need. Make sure y'all are careful about how many decimal places you are asked to round your correlation coefficient to. You'll get a question counted incorrectly if you don't round correctly. All right. So then you get a part of the question that says test the significance of R at the 5% level and the 1% level. A lot of hypothesis testing concepts are beyond the scope of this course, so we don't want you to get stressed out about this. We have even made an Excel worksheet to help you with this and tell you whether the R is significant at either one of these levels. But just to give you a little insight into what this is doing. You really cannot tell from just looking at an R value whether it's a strong enough R value to be considered a significant relationship. And researchers are seeking evidence to determine whether their variables that they're studying are showing a significant relationship. So there's just a lot more to this process beyond the scope of this course where researchers have other things they look at to determine if results are significant. What the 5% level and the 1% level are referring to is confidence. If you test the significance of R at the 5% level, then it means you want to be 95% confident in your conclusion. If you test the significance at the 1% level, it means you even want to be more confident, and it means you need to be 99% confident in your result. So when you look at this table, let's suppose, let's go back. Our sample size for this problem was 6. We had 6 ordered pairs or 6 points, 6 observations. So our sample size is 6. So these two numbers next to the 6 are telling you that a correlation coefficient would need to be at least an absolute value of 0.811 in order to be considered significant if you want to be 95% confident in your result. If you want to be 99% confident, you need even a stronger correlation coefficient for sample size 6. You would need it at 0.917. Okay. Now, this can get confusing. And as I said, a lot of this is even beyond the scope and would be taught at a higher level. So we've got this worksheet to help you test the significance. So I want to show you that right now. It is where you can find it is in the Unit 5 and Unit 6 live binder. So I'm going to open up this worksheet. I need to go back and remember that our correlation coefficient that we had calculated was negative 0.959 if I round it to 3 decimal places. And I've got to go check how many places it wanted actually back here. Let me go back, scroll up here. Yeah, 3 decimal places is what it wanted. And again, so important to check decimal places throughout your assignments. And that's true throughout this entire course. All right. So then I can go to my worksheet. When you get those ALEKS questions that ask you, is the R significant at the 5% level or at the 1% level? You can come to this worksheet that you find in the live binder, and you can just type the information in the yellow boxes, and it will automatically tell you if it's significant or not, so that you don't really have to learn too much about how to read the table and that kind of stuff. So sample size is 6, we said. Correlation coefficient was negative 0.959 if I rounded it to 3 decimal places. And then when I click this last box, there's a little drop down. The drop down is to tell whether you're trying to find out significance at the 5% level or at the 1%. So let's suppose I'm testing at the 5% level. I'll click this first number there, and notice the program automatically tells you, yes, it's significant. It is meaningful to go ahead and form what we call, or to conduct what we call regression analysis. You know, if you want to learn the table by hand, all you do is look up sample size of 6, go to the 0.05 and realize you need an absolute value of at least 0.811. Well, if you take the absolute value of negative 0.959, that has an absolute value that's higher than 0.811. That's why we're getting a yes. Okay. Like, let me just to show you, let me suppose I had picked a number that was not as high as 0.811. Let's pick 0.712, just hypothetically. Then when I press enter, notice it says no. That's not a strong enough correlation in order for it to be meaningful to try to do regression analysis. That's because we already can tell from our table over here that it needed to be at least 0.811, and it's not. So you really don't have to worry with reading the table because of this worksheet. But, you know, it's always, in my opinion, it's nice to learn kind of what's going on here. All right, so that's how you use the significance R worksheet provided for you. The next thing that I have written down is to find the equation of the regression line. So let's go back to our scatter plot, and here's how Excel will give you the equation of your regression line. And y'all, the regression line is otherwise known as the best fit line. It's a mathematically derived line that comes as close as it possibly can to all of these points. So it serves as your prediction model. And you'll see throughout these units how it can be used to make predictions about real life variables. It's really, really, regression is used so much out in the business world, the medical world, such a big variety of applications that exist with this stuff. Okay, so here's how we do it. To find the equation of the line, I'm going to take my mouse and left click it on top of my chart so that I can get this plus sign to appear. I'm going to click the plus sign, and I'm going to go down to the bottom where it says trend line. Notice without me even clicking anything, it's got the line drawn. And that's because by default, Excel will do linear trend lines rather than other types of trend lines. But I'm going to click this little arrow next to it. So I'll go ahead and check the trend line, click the arrow next to it, and I want to go down to more options. at the bottom. You can see why it automatically graphed a line, because by default, the linear radio button is the one that's clicked. But what I'm interested in is getting the equation of that line automatically. So I come down to these bottom two boxes where it says display the equation on the chart and display R squared. R squared is not important in Unit 5, but it will be in Unit 6. So I'm already showing you how to get it here. Click that. And I'm going to click and drag this up a little bit just so I can see it better in the white space. And there's your equation. Y equals negative 1.2439x plus 19.634. So messy stuff, but what's so nice is Excel can automatically calculate this for you. All right, so I'm going to write this down so I can show you a few more things. That's how you get the equation of your trend line. So let me go back to the Alex question. Skip that part because I've already shown you how to check the significance. Skip that part. All right. So part 5, find the equation of the regression line and draw the line on the scatter plot. Round the slope and y-intercept to 4 decimal places. Okay, I've already showed you how to get the equation of the line. Just make sure you're careful about rounding. And what you really have to be careful about is notice with your text, the X variable is over here and the number by itself is here. It switches it from the order that Excel gave it in. So you have to be really careful about the fact that you take that slope number that's in front of the X and put it over here in the second box. Let me show you what I'm talking about. See how the X term comes first in Excel. Well, the negative 1.2439 is the number in front of the X. So in your Alex program, you're going to have to remember now to switch that to this second box right here. So you're basically just flipping those numbers around here. And then skip that part, let y'all do that. Excuse me. And we will go to this last part where you have to graph the line. This is once again where you want to not try to figure out, guess where these numbers are. They're too messy. What I would do is plug in 2 values of X. So if I look down here on the horizontal axis, I see the numbers at 0, 1, 2, 3, 4, and so forth. So I might plug in a 0 and with my calculator get a Y coordinate. And then I might plug in something like a 12 or 13 or something, any number along here, and plug that in for the X so that all I really need to graph the line are 2 points. Okay. So what I'm doing now, although you can't see me, is I'm taking my calculator and I'm plugging in an X value of 0. Well, when I do that and put that in my calculator, it gives me this number, 20.5365. So I would go to this little part that I showed you earlier, click on that, and put in the ordered pair 0, 20.5365 and let it plot that point. All right. It's already plotted that point up here, or it's plotted that point as a little X up here. Then I'm going to grab my calculator and put in the number 12 for the X. I'm just picking, you can pick anything along these X numbers. So I'm going to do 20.5365 minus 1.4756 times 12. And I'm getting a number, so I'm going to put in 12, I'm getting a number of 2.8293. Plot that point, it's that little X, and now here's how I can graph the line. So you only need 2 points. You don't need to put in any more than that. All right, X that out. Here's how you graph the line. You take this line tool right here, but you have to place it on top of that first little X and click your mouse, left click your mouse. Come down to that second little X point, put the little vertical and horizontal grid lines crossing right at that X and left click my mouse there so that the program, the Alex program, has now connected a line between those 2 little X points, and that should be what works. We could check it. Hopefully we're going to see a green check. Fabulous. All right. So lots to learn and just, some tricky technology things this unit, but you can do it. You just get in there and practice. And hopefully you're going to give yourselves lots of time this week to work on getting through the learning curve of Alex and excel with graphing lines.